Good morning, I'm Sri Aksha, and today I'm going to explain you about the concept of energy consumption in the subject of basic electrical engineering. So, basically, what I'm going to explain you is in our houses we are using lights, fans, refrigerators, AC, laptops, and so many other electrical appliances, right? So, for that usage, we need current and we are getting current bill for that usage. So for that usage we are getting current bill. So how that current bill is calculated and how your energy consumption in a particular house or in a particular industry is calculated, we are going to learn now. So it is simply how many units of energy is consumed, that is power. How many units a particular house is consuming, according to that units how much bill that a particular house is going to get. So it can be calculated in 4 steps. First, device wattage into hours used per day equals to device usage in watts per hour. Suppose you are taking one device, you want to calculate for a bulb or a tube light. You need to take the wattage of that device, that the wattage device is specified on that box or on the label of that device. You need to take the device wattage into hours used per day. Suppose you are using it for 10 hours, 10 into device wattage. So the device wattage which is in the wattage into hours used, that will give you the device usage in watts hour. But we want in kilowatt hours because our current bill will be calculated in units, right? 2 units per day, 3 units per day, 5 units per day, etc. So based on the units it will be calculated. 1 unit equals to 1 kilowatt per hour. And second step is device usage in watts hour divided 1000. Device usage in kilowatt hours. So we have to convert watt hours into kilowatt hours. So for that we have to do is device usage in watt hours is divided by 1000. We will get the device usage in kilowatt hours, which is nothing but units. How many units? And third step is device usage in kilowatt hours into 30 days. It gives monthly usage in kilowatt hours per month. Device usage in kilowatt hours into 30 days. Why 30 days means we are using it for 1 month and we want to calculate it for 1 month, right? So 30 days will give us the monthly usage for the device. Only one device I'm telling. Like that we have to calculate each and every device in our home and add everything so that we will get the total current bill. And fourth step is monthly usage into cost per unit. Gives cost per month in rupees. Next, once we will get the monthly usage, we need to do monthly usage into cost per unit. For 1 unit, what is the cost needed to multiply? That means we will be getting the cost per month in rupees. And this is for one device. For example, 125 watts is used 3 hours per day. So if we are using a TV which is 125 watts and we are using it for 3 hours per day. So first we got the value, we will get the value in watt hours. First step, 125 watts into 3 hours gives 375 watts per hours. So we are getting value in watt hours. We need to convert it into kilowatt hours. So we have to convert it kilowatt hours by dividing with the 1000. So second step, that is 375 watt hours by 1000 gives 0.375 kilowatt hours. So next step, 0.375 kilowatt hours into 30 days gives 11.25 kilowatt hours per month, because we are using it for 1 month. That's why we are multiplying with the 30. And next, 11.25 kilowatt hours into 2.60 rupees, that gives 29.25 per month. So because per 1 unit, the cost of the unit is 2.60 rupees. So it depends on the usage. For 1 to 50 units, the cost will be something. For 50 to 100 units, the cost will be something. It varies. Based on that, we need to take. So we got 29.25 per month. Is for what? It's only for television. So we need to calculate for every electronic device, and we need to add everything. Then we will get the monthly current bill. This is how to calculate the energy consumption. Power factor. Power factor is defined as the ratio of reactive power to the apparent power, and it is a measure of how efficiently an electrical current is converted into a useful work. And we know that cos theta equals to adjacent side by hypotenuse side. Here when we see this, cos theta equals to real power by hypotenuse, means here Pythagoras theorem, that is hypotenuse square equals to side square plus side square, that is real and square root of real power square plus reactive power square. And next, how to improve the power factor. Power factor improvement involves the reducing of the phase difference between the current and the voltage by adding capacitor in a parallel with the inductive loads. When the power factor equals to 1, it means it is in the efficient condition. If we bring the reactive power to the 0, then we will get the power factor equals to 1. That means we will pay bill only for the used power. In order to reduce the power amount of the bill we pay, we need to improve the power factor. And there are 3 methods to improve the power factor. They are the static capacitor, synchronic condenser, and the phase advancer. And first one, static capacitor. Static capacitor is an electrical component that stores energy in the form of an electric charge, and it is used to improve the power factor. In static capacitor, we place a capacitor parallel to the load. That means if inductor means current will be lagging and the voltage will be leading. In capacitor, current leads and the voltage lags. So reactive power means, which is a inductive component. That means their current lags. By providing capacitor in parallel to it, we are neutralizing the lagging current by adding leading current. So to eliminate the lagging current, that means the reactive power, to bring the reactive power to 0, we are adding capacitor. By adding leading current to the lagging current to neutralize. Hence there will be the improvement in the power factor. And the advantages of these capacitor is low losses, less maintenance, lightweight, and easy to install. And the disadvantages, age of the capacitor is less. Once damaged, fixing is expensive. That means if once it gets damaged, it will be cost a lot to fix. And second one is the synchronous condenser, which is also known as the synchronous capacitor. It is a DC excited synchronous capacitor motor running at no mechanical load. It is used to improve the power factor and voltage regulation in electrical power systems by generating and absorbing reactive power. A DC excited motor whose shaft is not connected to anything, it runs freely. That means no load condition. Synchronous capacitor gives leading current, which neutralizes the reactive power. Reactive power means inductive component. So by providing leading current, we will neutralize the lagging current. So the advantages of the synchronous condenser is a long life, low maintenance. Disadvantages are it produces noise and expensive. And third one is phase advancer. Phase advancer is an AC exciter mounted on the same shaft of an inductive motor, and it improves the power factor by supplying leading current by counteract the lagging current which is drawn by the motor, and effectively improving the power factor. It is mainly used to improve the power factor of an induction motor, and it is connected in parallel to the motor. The phase advancer will provide the leading current. The advantages of these phase advancer is easy to use, and the disadvantages are not suitable for the motors below 200 HP. Thank you.